Electricity contributes to advances in science, medicine, and technology, helping to improve our quality of life. Working for us every day, in our homes, on our jobs, while we relax and play. Union Electric Company is pleased to bring you this program as part of our continuing community service activities.
Sight. It's one of our most precious senses. In order to see, we depend on light. When an object is seen, it may be the result of emitted light or reflected light coming from the object and forming an image on the retina. The retina is an array of photoreceptors and connected nerve cells at the back of the eye. The retina translates the image into nerve impulses, which are carried to the brain. Without light, we are unable to receive these pictures. Together, the eye and our mind create sight from this light energy. But the human eye is limited. In order to overcome this limitation, we have found a way of extending sight from the microcosm to the macrocosm. This urge to see more made a major impact on the way we view the world around us. One of the most important tools in extending what we are able to see is the microscope. Since its invention in the 1600s, it has revolutionized science. And now, science is revolutionizing the microscope. In this edition of Science Screen Report, we'll discover some of the latest advances in microscopy, including a microscope that enables us to see things 100,000 times smaller than we can see with the unaided eye. Imagine having microscopes for eyes. Common sea spray, or even pond water, would take on a strikingly different look, as does this cabbage leaf under magnification. An ordinary magnifying glass is a good example of a simple microscope. It has only one lens. It can magnify clearly, perhaps 10 to 20 times, but is limited to that. The compound microscope, which has 2 or more lenses, is a great improvement. We've come a long way since Robert Hooke's book, Micrographia, was printed in London in the 17th century. In it was his account of some of the earliest works with a compound microscope. Flawed and imperfect as they were, these early microscopes altered our perceptions from the very beginning. As our understanding improved, their practical impact on the world grew. Soon, scientists witnessed cells dividing and began to understand that microbes cause disease. Medicine took a giant leap forward. As the microscope changed the perceptions of science, science built better and more powerful instruments. Witness the power of microscopy by looking at these diatoms, a distinctive group of single-celled algae invisible to the human eye. By magnifying blood cells, we can better understand how our body works. The mysteries of life become clearer when you see sperm here with glowing heads or when you're able to see what happens after a sperm mates with an egg. The microscope can also help us identify some characteristics of bacteria. The MacArthur microscope is unique among the optical microscopes. It's as good as any bench instrument, but only 4 inches long. It also has a removable eyepiece which slots into the base. This particular configuration can be used to examine large surfaces for structural damage. Because of its compact size and versatility, it has been used in just about every environment, from the icy cold Antarctic into the steamy rainforests of the Amazon, and above the clouds atop some of the world's highest mountains. Optical microscopes, like those typically used in the classroom, have improved over the years, but they are still limited in magnifying power. Optical microscopes cannot reveal the image of an object smaller than the wavelength of light itself. Because light is reflected from all different focal planes at once, it becomes harder to see inside thick specimens. Again, science has triumphed over its limitations. Molecular biologists took this problem to the lab and built a new kind of instrument called the confocal microscope. It uses a laser light source and gives the user the ability to see inside thick specimens and into the heart of single cells. The confocal microscope focuses on only one focal plane at any given time. What was once a blur is now seen clearly. Now the eye of a water flea can be seen plane by plane, step by step, slice by slice. With the help of high-tech microscopes, molecular biologists are able to see inside the nuclei of cells. Why do they go haywire and become cancerous? These instruments may provide some of the answers. But even with laser light and flawless glass, microscopes still have limitations, something inherent in light itself. After all, light is merely energy in the middle of a spectrum, which stretches from radio waves at one end to gamma rays at the other. A study of potential sources of radiation of a shorter wavelength than light and their applications to microscopy ultimately gave rise to the electron microscope. Electrons are very small negatively charged particles of matter which have wave properties. The faster a beam of electrons, the shorter the wavelength. Electron microscopes work by focusing a beam of electrons with magnets. While light microscopes can see bacteria, electron microscopes can see the viruses preying upon them. There are 2 kinds of electron microscopes. The transmission type behaves like a light microscope. In this case, the beam passes through the specimen and is collected on the far side. And because it's electronic, the picture can be manipulated. The scanning electron microscope is one of science's prized possessions. The electrons do not pass through the specimen, but are reflected from its surface. A beam of electrons is aimed at the specimen, and a collector arranges the images sequentially. Within a few years of its invention, the scanning electron microscope has become a popular tool in most of the world's major labs, revealing secrets in chemistry, physics, medicine, and many other disciplines of science. Now, with our own eyes, through an electron microscope, the world is seen with new depth. Smooth bugs are strangely hairy. We are the first generation ever to see life on Earth through this window. Who would have expected to be able to see a pollen grain like this? Even more unexpected was the sharp 3D clarity of the images. The scanning electron microscope worked beyond all expectations. It was the biggest leap in microscopy since the 17th century. But it too has its limitations. Nothing living can withstand its deadly beam. With it, you can only see lifeless husks. Soft-skinned things must be freeze-dried and delicately clad, usually in a film of gold. And there is another drawback. Electrons and other particles in air break up the beam. It can only work in a vacuum, like that of deep space. Even with those disadvantages, we're still able to see things we never imagined, like the recurring patterns in the eye of a fly. The next generation of electron microscopes was invented by using a smaller aperture and by reducing the tail of the beam. The scanning transmission electron microscope can magnify up to 25 million times. Researchers who work with this microscope say it has the unique capability of drilling the smallest holes in the world, holes which measure 1 nanometer across. A nanometer is 1/1000th of a meter. The first scanning transmission electron microscope was built in the USA. It was a tremendous contribution to science, especially in manufacturing computer electronics. It has enabled us to make microchips smaller than ever before. By incorporating X-rays into microscopy, scientists had to overcome a few stumbling blocks. X-rays are hard to focus and carry no electric charge. To overcome this obstacle, researchers devised a zone plate. The zone plate works by the diffraction of radiation. The X-rays must pass through a series of finely spaced lines. The ridges in the plate block the rays, and the hollow areas focus them to a point. Ironically, the plate itself is made with an electron microscope. With the X-ray microscope, you can see live specimens, like these muscle fibers. And unlike the electron microscope, there is no need to apply a gold coating. Stepping even further ahead in the new generation of microscopes is the scanning tunneling microscope. This particular device calls for each specimen to be lodged in a vacuum chamber. Its measurements are so accurate and the procedure so delicate that it must be cushioned on shock absorbers of air. The scanning tunneling microscope can find the slightest imperfections, and for this reason it is widely used in the semiconductor industry. In a silicon conductor, the quality of a crystal strongly influences how well it conducts electricity. Defects in the crystal itself can trap electrons, which alter the way the silicon will behave as a device. Now, scientists can look at individual atoms on a surface to a resolution which is impossible by any other means. Science creates abstract paintings from X-ray crystallography, designed to show the inner structure of matter. Pattern, structure, form. The microscope shows us the same simple shapes repeating themselves from microcosm to macrocosm. Nature uses the same chemical codes, the same DNA, altered only slightly, but enough to create a myriad of living things. Science has yet to slow down in its attempt to see more of the microcosmos. Some of the latest discoveries in microscopy exploit sound waves. The acoustic microscope has proven useful in the non-destructive examination of integrated circuits, electronic components, and even living cells and tissue. Other advances in microscopy include the use of high-voltage electrons and electron clouds. As this indispensable scientific tool becomes more powerful, we can learn more about extending our lifespan. build structures which are virtually flawless, grow super crops, and help eliminate killer disease and famine. The microcosmos is extraordinarily rich and complex. The more we see of it, the more we appreciate the beauty of our environment, and the more we realize that events in the microcosmos affect us all.
This program has been sponsored as a public service by Union Electric Company, serving more than 1 million customers in communities throughout Missouri, Illinois, and Iowa.